So higher order homogeneous PDE with constant coefficients. In this, right? So we have actually very simple method, that is, suppose if I have this equation f of d comma d dash is equal to, so g of ax plus by. So if this is the format of the differential equation, so this is a partial differential equation where d and d dash represents, d is dou by dou x and d dash is dou by dou y. So d is dou by dou x and d dash is dou by dou y. So the terminology, that's what we are going to use, is d square is dou square by dou x square, and similarly d dash square is dou square by dou y square. Sometimes this is represented as dx, so this is dou by dou x, and similarly sometimes this is also represented as dou by dou y as dy, right? So if this is the function, any random function of d comma d dash, and the right side function is of the form ax plus by format, then the complementary function you can find out. So in this, right, so auxiliary equation for this is, so auxiliary equation will be f of d comma d dash equal to 0, and then solve for the equation for the solutions of f, then write the complementary function and then the particular integral will be, so 1 by f of a comma b. So instead of d, this is a, and instead of d dash you have to substitute the b value, right? So this is the standard method, and then whatever the function you are going to give, so this is g of v, I call v is equal to ax plus by, then integrate this, so dv dv, so this is 2 times, which is the order of the homogeneous equation. So this is the standard method. So this is the order of the differential equation. Now let us say if the order of the differential equation is 2, you have to integrate 2 times. If the order of the differential equation is once, then you have to integrate with respect to v once. Suppose if the order of the differential equation is 4, then you have to integrate 4 times, but the same function with the same variable. Got it? So this is the standard method of writing the complementary function and the particular integral. Got it? Any questions on this? Do you have any questions on this? Okay. Fine. So based on this, so this is the only method we have it, and we will solve the problems based on this understanding. Solve d square by d square plus 3d d dash. Solve d square plus 3d d dash plus 2d dash square equal to d dash square of z is equal to x plus y. So solve this one. For that, actually you have to identify the complementary function first. and then the particular integral. So in the particular integral value, a value and b value is equal to 1. So that is the case in this case. So here actually, so d and d dash. So auxiliary equation is, so you can write this as, sorry, this is d square. So the order of the differential equation is 2. So order is 2. Then auxiliary equation will be m square plus 3m plus 2 equal to 0. So this is the auxiliary equation, and this can be written as m plus 2m plus m plus 2 equal to 0. And if you take m out, m plus 2 plus m plus 2 equal to 0, or m plus 1 into m plus 2 equal to 0. It implies m equal to minus 1 and m equal to minus 2. Then the complementary function will be, so arbitrary function of y minus x plus, so this is phi 1 and this is phi 2 is another arbitrary function y minus 2x. So this is the complementary function. And to find out the particular integral, pi is equal to 1 by f of d comma d dash, and then operated on x plus y. So this is x plus y is of the function of ax plus by. Now in this case, here a is equal to 1 and b is equal to 1. So if this is the case, then you can substitute in the equation. This is d square plus 3 into d dash plus 2 d dash square operated on x plus y. Now this is going to be 1 by 1 square plus 3 into 1 plus 2 times of 1 square. So operated on x plus y. Then this is going to be 1 plus 3 plus 2. So this is 1 by 6. And then I call this as v. And then integrate 2 times, because the order of the differential equation is 2. So this is d square. In the homogeneous equation, this entirely contains the power 2. So 2 here, 1 plus 1, 2. So this is a homogeneous equation. So v dv you need to do 2 times, where v is equal to x plus y. And then this is 1 by 6 times of integral v is v square by 2. And again do the integration with respect to v. So this is 1 by 6 times of v cube by 6. And then substitute the values, that is 1 by 12 times of x plus y whole cube. So this is a particular integral. So complete solution will be CF plus PI. So this is the complete solution. Got it? Sorry, 6 in 6 is 36. Yeah. Got it? Yeah. So this is how actually you should be solving the particular integral for any partial differential equation. Note down one more. So did you note it down? So note down this, r plus s minus 2t r plus s minus 2t equal to 2x plus y whole power 1 by 2. So this is the partial differential equation. So the standard convention, r you should be aware, dou square z by dou x square, and s is dou square z by dou x dou y, and t is dou square y z by dou y square. So this is the standard convention. So keeping this convention, can you solve this differential equation? Yeah, what about the particular integral? So the complementary function is coming out to be phi 1 of x plus y or y plus x and plus phi 2 of y minus 2x. This is the complementary function. What about the particular integral? Hello. Yeah, sorry. So I got a call in between. Yeah. So see this. So this particular equation, so we have actually rs minus 2t. So r plus s minus 2t. R is dou square z by dou x square, or actually I call this as d square, and then plus s is d dash minus 2d dash square of z is equal to 2x plus y whole power 1 by 2. Now the auxiliary equation is m square plus, so m minus 2 equal to 0. So this is the auxiliary equation. So the solutions for this is, so this is m is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So this is minus 1 plus or minus, so 1 plus 8 is 9, 9 root is 3 divided by 2. So this is minus 4 by 2 and 2 by 2. So this is m values are coming out to be plus 1 and m is equal to minus 2. So these are the two different auxiliary equation solutions. So obviously the complementary function will be CF, you can get it as, so this is phi 1 of, so this is the complementary function. So I think Deepak already gave this. So this is the complementary function. And coming to the particular integral, so you have to calculate the particular integral 1 by d square plus d dash minus 2d dash square operated on the function 2x plus y whole power 1 by 2. So on this cycle we have to operate it. For that actually I have given a standard format 1 by f of a comma b operated on ax plus by. First you substitute the value of a and the value of b here for the function. Now here a is 2 and b is 1. So 1 by 2 square plus 2 into 1 minus 2 into 1. So, and then operate on 2x plus y whole power 1 by 2. Now this is, so 2 will cancel, then 1 by 4. Now if you want to operate this 2x plus y whole power 1 by 2, what you need to do is integrate 2 times d of 2x plus y, or 1 by 4 times of double integral. So this is v power 1 by 2 dv dv. So this you have to integrate 2 times. This is the methodology for finding out the particular integral for any function of the form of ax plus dy on the right side. So this is ax plus by. So this is g of ax plus by format. So where g is a function which is given as 2x plus y whole power 1 by 2. Now this is the particular integral methodology. Now if you integrate once, then this is going to be 1 integral v power 1 by 2. So 1 by 2 integration is 1 by 2 plus 1 divided by 1 by 2 plus 1 whole power 3 by 2 divided by 3 by 2. And then again integrate with respect to v only. So this 2 times because the order of the differential equation is 2. So if the order of the differential equation is 2, then actually we have to integrate 2 times. So one more integration is 1 by 4 and then 3 by 2 is out, and then integration of v power 3 by 2 is v power 5 by 2 divided by 5 by 2. So this is 4 will cancel, and then 15 v is 2x plus y whole power 5 by 2. So this is the particular integral. So CF plus PI is the complete solution. Got it? Understood? Yeah. So this is the standard methodology which you can adopt for any kind of equation which contains ax plus by format. Note it down. Okay. So note down one more. Solve dou square z by dou x square plus dou square z by dou y square is equal to cos mx cos ny. Solve dou square z by dou x square plus dou square z by dou y square is equal to cos mx cos ny. Can you solve this? So try to bring the format of ax plus by format for cos mx and cos ny, and rest of the procedure is as it is. Anybody got the answer for this? So complementary function you can anyway do it. So this is d square plus d dash square. So this is equal to 0, or m square plus 1 is equal to 0. So m is equal to plus or minus I. So then the complementary function will be phi 1 of y minus ix plus phi 2 of y plus ix. Yesterday somebody asked for the imaginary roots. Now this is the imaginary roots. Now the complementary function will not change. You can take as it like it is a complex number. Got it? And the particular integral value, if you want to find out, first you have to convert this into cos ax plus by format. Now cos c cos d is, this can be written as cos a plus b cos mx plus ny plus cos mx minus ny divided by 2. So this is how you can convert. Now it is like ax plus dy format. So the particular integral value you can find out. So 1 by d square plus d dash square operated on cos mx plus ny plus 1 by d square plus d dash square operated on cos mx minus ny. So you have to operate on this. Now this is 1 by m square plus n square, and then so this is a second order differential equation. So d square and d dash square. So hence 2 times integration on cos v dv dv. Got it? So this is how you have to do it. Similarly, here also 1 by m square plus minus n whole square, and then 2 times integral cos v1 dv1 dv1 2 times. So here 1 by m square plus n square you can take out. From this integral cos is derivative of sin is cos. So cos integral is sin v dv, integrate it again. Similarly, here also v1. So integral cos is sin v1 dv1 integral. So this is 1 by m square plus n square, and then integral sin is minus cos. So minus cos v minus cos v1. So this is the particular integral. You can substitute the value of, so minus, you can take it out, minus 1, and then cos of mx plus ny minus cos of mx minus ny. So this is the integral, particular integral. Got it? Understood? Yeah, that's correct, Nitya. Note down one more. This is a little bit tricky. So dou square z by dou x square minus dou square z by dou y square is equal to x minus y. Can you solve this? So this is minus and this is x minus y. Solve this differential equation. You will face certain issues in this differential equation. This is the other case. Anybody got the answer for this? Anybody got it? So the particular integral value is, I think that's not correct. Anybody else? So did you not face any issue on this? Here actually the complementary function is straightforward. This is m square minus 1 equal to 0. So m is equal to plus or minus 1. So m is equal to plus or minus 1. The complementary function will be phi 1 of y plus x and phi 2 of y minus x. Yeah. So this is the complementary function, and the particular integral is going to be 1 by d square minus d dash square operated on x minus y, right? So here the problem is, if you substitute 1 here and substitute minus 1 here, and then 1 minus 1 is coming out to be 0. This is the problem. Got it or not? Understood this one? So in this case actually we say this as the case of failure. So in the case of failure, first actually try to identify whether you can simplify this further. So this actually we can further simplify as 1 by d plus d dash into d minus d dash, and then operated on x minus y. Now here you can independently operate each factor. Now the minus 1, so this is plus 1 and minus 1. If I put it here, this is the problem. So this is the case of failure. So this is the case of failure, and this value 1 minus of minus 1 will be plus 2. So this is no issue, but for this it is having issue. Now in this case what you need to do is, first actually operate only d minus d dash. So this is 1 by d plus d dash, and then substitute 1 minus of minus 1, and then integrate once, that is x minus y into d of x minus y. So integrate once. This is not yet operated. Then this is 1 by 4, 1 by 2, and this is d plus d dash, and then if you integrate this x minus y whole square by 2. So but this is not operated yet. So this is 1 by 4 times of 1 by d plus d dash. Now we have to operate on x minus y whole square. Now here, because this is a case of failure, so in case of failure, what happens is you have to identify. So this is the order of the factor. Here in this case 1, suppose let it be n. In case if it is n, the solution straight away you can write as, so depending upon this n, so x power n divided by b power n into n factorial, and then operated as it is. That is phi of or g of x ax plus dy. So this is the solution in case of failure. So here b power n. So if this is of the form ax plus by, then b power n and n factorial g of ax plus by. So whatever the function it is there, straight away the same function comes here, and x power n comes as a multiplication here, b power n n factorial. Here this n is nothing but the order of the factor. So this is a first order factor, right? So here in this case n is equal to 1, b is equal to minus 1. So minus 1 whole power 1, minus 1 whole power 1, and then 1 factorial and x power 1 into x minus y whole square. That will be the final solution. This is going to be 1 by 4 times of x minus y whole square, and then so b power n, so minus 1 whole power 1 into 1 factorial, and then as it is the function is operated, then this is going to be minus 1 by 4 times of x minus y whole square. So this is the particular integral. Got it? Understood? So in case of failure, this is the standard methodology which you can adapt. So for the function of ax plus by. If it is not in the format, then actually we will bring into that format. Clear? Any questions on this? See this. Okay, so you note down this. I am going to explain that formula. So this one, suppose, so 1 by f of a comma b operated on ax g of ax plus dy. Suppose if it is a case of failure, then the particular integral will be, this comes as it is g of ax plus by, and then here x power n, so and denominator b power n into n factorial, where n is the order of the factor which is responsible for case of failure. So in this case, so d plus d dash is a first order factor, right? So hence n is equal to 1. Got it? B is minus 1, which is the coefficient of y. Yeah. So this is how actually you can apply in case of failure. Okay. So another model. So there are another models, that is equations reducible to homogeneous format. So equations reducible to homogeneous format. Ideally these are not homogeneous, but we can reduce. So this is, suppose if I have the equation, just note down one problem, x square dou square z by dou x square x square dou square z by dou x square and y square minus y square dou square z by dou y square minus y dou z by dou y plus x dou z by dou x minus y dou z by dou y plus x dou z by dou x equal to 0. So look at this equation carefully. So this is Lagrange's form of the homogeneous equation in case of ordinary differential equations. But here, because there are two independent variables are there, for dou z by dou x, so for dou x square, it is x square multiplied. For dou y square, it is y square multiplied. And this is y with y and x with x. So if this is the case, so this is what we call as Legendre format, I think. So this is the normal ordinary differential equation, whatever we do, the same procedure even here also we will be adapting. Now, d square is replaced with d into d minus 1 or d1 minus d1 minus 1. So this is how actually we replace. So the methodology what we are going to adapt is, so x is equal to e power u, you put it. Then it implies u is equal to log x. And then, so if you take dou u by dou x, sorry, so dou z by dou x, you can write as dou z by dou u into dou u by dou x, right? So here, this is dou z by dou u, dou z by dou x, sure, dou u by dou x is 1 by x, or dou z by dou x is equal to dou z by dou u times of 1 by x, or x times of dou z by dou u, dou z by dou x is equal to dou z by dou u. This is how you can replace it. So x times of dou z by dou x, you can replace with dou z by dou u. Similarly, if you take the derivative again on this, so the way you are going to get it is dou square z by dou x square, you will get as, so dou by dou x, sorry, dou by dou u and dou by dou u minus 1 times of z. So this is how actually you are going to get it. So this is what we write as in short form d1 into d1 minus 1 of z. But where d1 is dou by dou u, not dou by dou x. Got it? This is the standard methodology what we are adapting in case of ordinary differential equations when we solve the Legendre form of the homogeneous equation, which is nothing but this form of the differential equation. Now here, exactly in the similar manner, this you can replace as d into d minus 1, and here minus d dash into d dash minus 1, and then here minus d dash plus d. This is how you can write it. So this entire equation is d into d minus 1, or I call this as d1 into d1 minus 1, and then minus d2 into d2 minus 1 minus d2 plus d1 equal of z is equal to 0. Here d1 is dou by dou u and d2 is dou by dou v. Got it? So this is the methodology of reducing a non-homogeneous equation into a homogeneous format. Got it? So this equation contains no more x or no more u. It contains a plain differential a plain partial differential equation the way we solved in the previous problem. Got it or not? Only d1 and d2 are there. Instead of d, it will be d1. Instead of d dash, it will be d2. Got it? Understood? Now you can simplify this equation. Now the same procedure is adopted the way we have done in case of previous problem. Now based on this understanding, just note down this. Based on this understanding, so if it is a second order factor, d into d minus 1. If it is a third order factor, d into d minus 1 into d minus 2. If it is a fourth order factor, d into d minus 1 into d minus 2 into d minus 3. So till 1 less. So that is how actually this is going to be factorized. So that is proved based on this understanding. Got it? Any questions on this? Now based on this understanding, so let us solve this differential equation. So this can be replaced as that one. So that is d1 square minus d1 minus d2 square plus d2 minus d2 plus d1 equal to 0. So this d1, d1, d2, d2. So this is d1 square minus d2 square equal to 0. Or the complementary function is, sorry, auxiliary equation is, so m square minus 1 equal to 0. M is equal to plus r minus 1. So the complementary function will be, so phi 1 of, so this is y plus x. Usually it should be y plus x and y minus x. But here, instead of y I have used v, instead of x we have used u. And here also, so this is v plus u plus phi 2 of v minus u. So this is the complementary function now. But the relation between x and u is equal to log x and v is equal to log y. So this you have to replace it. So phi 1 of, so v is log y plus log x plus phi 2 of log y minus log x. So or in other words, phi 1 of log y by x plus phi 2 of log y, so this is xy and this is y by x. Yeah. So this is the complementary function. Got it or not? So the same methodology whatever we are going to adapt in case of ordinary differential equations, just we have replaced x is equal to e power u. So that is what we substituted. So from this actually if you take the derivative of z, dou z by dou x you can replace as this one. So d into d minus 1 where d is dou by dou u. So dou square by dou, so here actually d square and this is minus d. That means this is dou square z by dou u square minus dou z by dou u, you can replace it. So this can be replaced with like this, where x is no more, we got in u. Got it? Understood or not? Do you have any questions on this? Any questions? Okay, so this is the standard methodology. So these are the different kinds of models actually that we are going to solve as part of homogeneous differential equations and the equations that are reducible to homogeneous differential equations. Got it? So I am going to give an assignment based on this understanding, right? So this is about the homogeneous differential equation. So do you have any questions on this or in the previous topics? Okay, yeah. So that's all for today. Yeah, so let us see in the next class. So I think very few topics left over. One is the canonical form and Cauchy's method of characteristics and applications. That's it. It won't take much of time. So because on the right hand side if it is 0, there is no function on the right hand side, then no more particular integral it will be. So particular integral calculation will be as it is the way we have done in case of the previous problem. But that particular integral comes into picture only if there is a function on the right hand side of the equal to sign. Otherwise, no particular integral.